Hello everyone, welcome to another video. Today in this video I'll be discussing quadratic equations. So it's a part 2 of my previous video. In the last video we discussed how to use the null factor law and the middle term factor law, and we also discussed the standard equation, the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. Well, today we'll be covering two new equations, and that will be two new quadratic equations, and for the first one will be ax squared plus bx equals 0, while the second one would be x squared minus d squared equals 0, which can also be said x squared equals d squared. So you can put it both ways. Okay, to start off, we'll start with ax squared plus bx equals 0. And during these type of quadratic equations, the first thing we need to do is factorize it as much as possible so we can use the null factor law to find what x is. So let's have an example in the form of ax squared plus bx equals 0. So let's say we have 2x squared plus 8x equals 0. Here we see that 2 equals a, part of the ax squared, while 8 is the b in bx. So now what we can do here is we can factorize this by a common number. So what can 2x squared and 8x be divided by? Well, it can be divided by 2x. So then this equation would then be implied as 2x multiplied by x plus 4 equals 0. So now we've got a much more straightforward equation where we can find x. In my previous video, I talked about how to use the null factor law. You should check that out if you haven't yet, because we'll be using that in this video. I encourage you to pause the video for a moment so you can figure it out. Okay, done. So, the way we find out what x equals is one of these terms has to be 0, because one of these numbers has to be multiplied by 0 in order to equal 0. So either x plus 4 equals 0 or 2x equals 0. So if we assumed 2x equals 0, that means x either equals 0, so x either equals 0, or if we wanted this term to equal 0, x would have to be negative 4, because negative 4 plus 4 equals 0, so if you're multiplying something with 0, it automatically equals 0. Now we can even substitute it to check if our answer is correct. So if we substitute negative 4, it would be negative 8 times 0, which equals 0. And now same thing, if we substitute 0, it would be 0 multiplied by 4, which equals 0. So we see that it works both ways. So let's try another example, and let's do, how about this? 3x squared plus 9x equals 0. Once again, we have to find a common factor between 3x and 9x, which can be divided. Well, 3x is a number that can be divided by both 3x squared and 9x, so we use that because that's the highest factor that we can use to divide both of them. Therefore, 3x squared, so we'll just put 3x here, so it's implied as 3x times, so 3x squared divided by 3x, that equals x, and then plus 9x divided by 3x, that equals 3. So 3x multiplied by x plus 3 equals 0. Once again, we can use the null factor law. So x would equal to either this term has to be 0 or this has to be 0. So if x plus 3 equals to 0, that means x has to equal -3. Similarly, if 3x equals to 0, then x has to equal 0, because 3 times 0 is 0, and 0 multiplied by any number is 0, which means the quadratic equation would be accurate. So our answer would be x equals -3 or 0. Once again, we can substitute to check if this works. Let's substitute -3 into x. So our equation would then be -9 times 0, which equals 0. That is true. And then if we substitute, let's say, 0 into this, that would be 0 times 3, which equals 0. So as we can see, if we use factorization properly in the form of ax squared plus bx equals 0, along with the null factor law, we can easily find what x equals. Okay, the second quadratic equation I would like to show you is x squared minus d squared equals to 0. And what that essentially means, x squared minus d squared is essentially the same as x plus d times x minus d. So this is another way of doing x squared minus d squared. Never forget this. It equals 0, and then from that point on we would try to find x. So let's use an example. Let's say x squared minus 4 equals to 0. This would be the same as, well, x is just x in the form of x squared minus d squared, and 4 can also be said as x squared minus 2 squared. So therefore the 2 becomes the d in x minus d squared. So we have to make this second term into a way where it becomes squared. Otherwise we cannot apply this quadratic equation. And yeah. So now we would do x squared minus 2 squared equals 0. And once again, I've already said that x squared minus d squared equals x plus d times x minus d. We would apply that same thing here. So x squared minus 2 squared would equal x plus 2 times x minus 2 equals 0. Once again, we apply the null factor law. So now x either equals, so either this term has to be 0 or this term has to be 0, and for x plus 2 to be 0, x must equal -2. So x either equals -2, or, and then in this term, for x minus 2 to be 0, x must be +2. So x equals -2 or +2 in order for that to equal 0, and we can just substitute it. So if we do -2 plus 2 times -2 minus 2 equals 0, that would then equal 0 times -4, which equals 0. So therefore -2 works as one solution. And then once again, we can also substitute in 2. So it would be 2 plus 2 times 2 minus 2, which equals 0. So that would be 4 times 0, which equals 0. So once again, this solution also works. So we can see that when it is in the form of x squared minus d squared, we can use x plus d times x minus d. And when it's in the form of ax squared plus bx equals 0, we can factorize in such a way and then apply the null factor law. The null factor law is incredibly important, and I suggest you keep that in your core until the very end of your high schooling time. I think that will be enough for today. Hopefully in the next video I'll be going along factorizing non-monic quadratic equations. And until next time, keep on learning.